Hi, good morning, everyone. I'm Daphne from Virginia Tech. Thank you so much for having me as a keynote speaker. Today, I want to say a little bit about my experience securing crypto code and what are the industry needs. Acknowledgement to my students, my colleagues, my former student senator, who is an assistant professor at Arizona, who lead the CryptoGuard project, as well as my colleagues at Oracle and Wisconsin Madison. Software is, of course, everywhere. Some cards have millions of lines of code. Ford pickup truck has 150 million lines of code. And so I wonder how to secure them. And part of for the Ford, probably because of the ECU, electronic control unit, just many of them. Also, devices are closer and closer to your body, impacting privacy and security. During the COVID era, one of the Virginia contact tracing app is called COVID Wise, and this is built on the Google Apple exposure notification library that I know Moti Young is one of the key figures behind it. Our lab has done some work in inspecting the privacy guarantees, and we find it's as expected, the strong privacy guarantees in terms of implementation. And so those are the practice that you want to confirm. You want to confirm that there are crypto principles. Are they faithfully reflected in the deployable solutions? From the software community, there are many security coding practice rules, principles, and then of course the number one rule that we routinely talk about in textbooks and in classes is validate input. But the developers also need tools to do static analysis. This is Microsoft Secure Development Life Cycle, which Microsoft recommended to the software development community. And you see during the implementation and then post-implementation, the verification phase, that we require dynamic analysis, the runtime checking, and static analysis, where you just look at, inspect the code without running it. And so I wonder, are there enough code? Are there enough tools for developers to use? And if there are, how good they are? And we all know that people do want to write secure code, but then sometimes because of the time, the budget constraints, the lack of training, and sometimes the tools have too many false positives and just make it a lot harder for them to be used in practice. And the more I look at this, the more I see the gap between the theory that we as researchers routinely understand, and then the practice, the first line of the defenders, software developers, and their understanding, and then their resources and the lack thereof. One of the example is Cross-Site Request Forgery, which if you look at all the basic cybersecurity college courses, this is one of the must talked about topic under web security, and it was raised. The threat was pointed out 12 years ago and very well studied. And so what is it? So essentially the browser, sometimes it's called confused deputy problem. The browser is confused and sometimes would automatically send credentials like cached cookies and session IDs to certain services that the victim, the user, has a valid session, ongoing session with. But then, however, this request is a spoofed one. It's coming from the attacker websites, and because of the user maybe accidentally load certain websites of the attacker site, and so but the browser didn't know, and so password got changed, the money gets transferred, and pretty devastating attack. And we all know there is, and then there's also cookie under a lot of the system, especially Java Spring framework, there's anti-CSRF cookie that you should enable a token. But then this is a real quote from Stack Overflow software developer forum. It says, adding cross-site request forgery, disable, solve the issue, and I have no idea why this this token was enabled by default. And so, understandably, a lot of developers, if you graduated way before 2008, and you never learned about this in class when they were in college, and these are also other real quotes from Stack Overflow developer forum. Setting certificate verification to true, skipping, and those are the real code being shared and also accepted as the accepted answer by other developers. And I really like this quote. It says, apparently this is an app developer writing app, client side app. And this person said that I only want my client to point to one server, say Facebook. If I'm writing a Facebook app, I only want, and I'm also assuming my client would only fire up the app in a way that will only directly connect to Facebook server, and that's indeed the intention. But however, if man in the middle attack, a lot of things can go wrong in the middle, and so. And we have done this work published in ICSI 2018, thoroughly study the dynamics, the practice that a lot of the struggle, the frustrations that software developers have. In particular, one of the confusing and also the damaging aspect is that several of the high-profile posts that advocating insecure code or configuration, for example, using MD5 will solve certain code compile error, was viewed many times. 17 posts viewed more than 600,000 times, and that was 2-3 years ago. Huge influence on developers. Interestingly, another aspect is that there's also some sort of cyberbullying happening on Stack Overflow forum, and one person said you shouldn't skip any certificate verification in TLS, and another person with more reputation, this is score 6,000, said that you should just shut up because you don't have any reputation around here. And so this is just confusing, to say the least to inexperienced new developers. And if you run a company and you don't, as say a manager may not necessarily reveal each line and every line of the code developers write, and so you have no idea what's going on, right? So you have devices, in your car, on your health monitor. It's devastating. Another issue that I realize is that the media really want eye-catching topics. They would exaggerate, they will spin the story, spin your finding in a way that would tailor to people's tastes. People want to see what in the news. They want to see disasters, okay, things not working. And so our work published in ICSI was at a time it was appeared in ARXIV forum, and one day people telling me that there's this report about your work, and I look at this, they said lazy developer. We never said lazy developers. We said developers need tools. Developers need help. And so let's look a little bit closer for crypto coding. And this is, was also very shocking to me because, we as a researchers so often want to do things at a very abstract level, cutting edge, but abstract. We don't care how code is written for real, right? Like we assume someone take care of it. But then it's so complicated, especially in Java. And this is a simple example, right? So you have a default key, this variable contain a string, and this string was eventually used as a constant key in AES encryption, which is of course bad. You should generate randomly, and then but then this type of that was a simple case. A more complicated cases, so maybe you have multiple classes in Java, multiple methods. Some methods are self-defined, and so you have to go into the methods, and then maybe it's multiple calling chains in the invocation, and to find out, okay, who is calling what and what is being passed around, and more complex data flow analysis. And also there are scenarios where you just have to be creative in terms of writing your rules, and so this is on the right hand side. This is for this is wrong, this is insecure. Hostname verification is very, very important in TLS certificate verification. You cannot just log it. If you get a reception, you have to throw an exception, otherwise the connection will still be established. And so one of our detection in CryptoGuard, which is a static data flow analysis looking to secure Java crypto API misuses, and then we, we look at things using obsolete hash function, constant keys, password-based encryption, not having enough iterations, and so on and so forth. And one of the first thing that we did, we realized we have to do is to map crypto properties into program analysis. And so crypto is somewhat abstract, sort of the mathematical patterns, and then there's very concrete operations you have to do on code, analysis, slicing, backward slicing, forward slicing, and so that's what we did. We have a way we manually put in this part is all done manually, and so it comes down to something that look like this, and we have 16 rules, and for a lot of the rules, those are patterns, vulnerability patterns, we look to identify how certain constants is being used, and so we manually select a certain slicing criteria, and then we look at to see what are the instructions, the Java statements that would use this object, or that's go down, and or that would impact the creation of this object, and so sometimes you go backward slicing, sometimes you go forward depending on the needs. Our analysis also support flow sensitivity, context sensitivity, interprocedural field sensitivity. We analyze Apache Software Foundation, big server code. We also look at Android apps. Android apps are written in Java. Interestingly, after looking at more than 6,000 apps, we find that the majority of the app are doing fine. 96% of the issues, the crypto-related, security-related issue come from the libraries and come from big companies, Google, Facebook, Tencent. And some of the issues are pretty severe, dummy hostname verifier, predictable password used in key stores. So we have disclosed those issues, but then we didn't get much enthusiastic feedback from some of the tech companies. So I'm going to show more examples. And this is the example of the crypto code. In the crypto code, sometimes is you thought crypto, and then you look at the Java code and you're like, I know nothing about crypto, and this is just for encryption, right? So it's just so many lines, and then you define multiple classes and just so complex. And the complexity creates an issue that is sometimes you generate false positives because a lot of the analysis that we did depends on finding constants, and then see whether the constant is used to specify the iterations in PBE, the password-based encryption, or the constants used as the encryption key, used as a salt. And so there's a lot of the analysis based on constant finding, but then most of the time the constants are irrelevant to crypto function and generating false positive. Our initial implementation generates so many false positives, and we all know false positives are so counterproductive. This is from in 2018, Hawaii had a false alert saying a ballistic missile was gonna strike within 30 minutes, and so it was just so unexpected. And a lot of times if you have too many false alarms, and developers were like, I don't want to use these tools because it's just wasting my time. And I did a lot of other work on intrusion detection, anomaly detection, and focusing on reducing false positives. And so in this case that we did a manual analysis, we find that some are file names are constant, but then in file names not very relevant. Encoding properties, specifying encoding properties. So we developed heuristics. We call it refinements, but they're really sort of policies that we say, oh, if you have this type of scenario, like index, array index, that under this type of pattern, this is very likely to be irrelevant, and we can ignore them. You don't have to consider, keep tracking of the flow. And so those we have 5 categories of refinement. They are able to reduce the false alerts to 80%. And so and not all rules, not all patterns involve this, only constant related. And so this is substantial reduction. And I would say from the design perspective, this is probably the biggest novelty that we had, reduction of false positive and realizing that the issue and then effectively reduce that. And so this enable us to be able to scan big project and then identify a small enough number of alerts that we can chase down. And so we find issues in those projects, and a lot of them are very high profile, and we disclose them and get positive feedbacks from some of the teams. And so the average line of code is 200,000 lines of code. And here's an example. It's a password-based encryption from Apache Ranger code, which is used in a lot of Hadoop analysis. So there are several issues. One of this is use MD5. This variable was defined as MD5, which is of course it's not secure, and then there's really no need to use it anymore. SOT is supposed to be independently generated random, pseudo-random number, but here is a digest of the password, right? So this is also a violation of what you expected to what the SOT to be. Here is the biggest thing, the iteration. A lot of people don't know, a lot of software developers don't know that it has to be 1,000 iterations and above. But here is the length of the password plus 1, and so clearly not enough. And also that create the issue of a side channel, because the iteration would, people by monitoring the runtime of this iteration will be kind of guess the password length, estimate the password length, which you reveal information. And so so we know how this should be implemented at a theoretical level, right? Specification level, but then there's the actual implementation. And I would say, any single one of these issues may not be a big deal, but then why not? Especially you don't know how this code is used, how sensitive, critical of the system is used, and so like for example, if you're familiar with Wi-Fi WEP, it's broken because RC4, the stream cipher, was not supposed to use repetitive keys. Right, so and you're breaking the cryptographic assumption of certain tools and certain algorithms, and just and hurting the integrity, the security guarantees of the system. And so I would say those kind of implementations need to be fixed, need to be hardened. So that you have a consistent understanding of the cryptographic guarantees, the security guarantees. We did this, we have a big team, we did a lot of manual confirmation to make sure that very few, only 18 false alarms generated among the alerts. Some of the issues come from we don't do pass sensitivity, and some of the issues related to the code not being understood as a non-security sensitive code. And so we are very proud of this particular contribution. It's called CryptoAPI-Bench. So besides putting together a tool, we also put together some test units. So almost 200 test cases. Some are basic cases, simpler cases. Some are, have more complex flows. Some of the cases are for just testing false positives, and they have no vulnerability, and to see whether any tools would recognize them as being negative. And so we are very proud that the benchmark was also used by state-of-art solutions, Cognitive use the benchmark to improve their solutions. Their solution, their detection is type-based. Coverity is the leading industry commercial solution. Is also, because we tested the benchmark against their tools first, and then after a while, and then we tested it again, and they have improved so much. And so I'm glad that it's not, producing one tool, but we want the whole industry to improve. And so I'm for a long time very curious, how do big companies do code scanners in the industrial strength code scanner? What does it look like? And so Christina Cifuentes and her team at Oracle has been building a static analysis tool for security since 2007, a long time ago, and it's called Parfait. Parfait is, they emphasize on scalability, being able to analyze tens of millions of lines of code in just a matter of hours. And Parfait is also very precise, and that's another goal that they try to optimize. And so they heard about our work, and we had a conversation, and one of my students, Ya, went there and did a summer internship in 2019, last summer. And so what Ya and her colleagues at Oracle Labs Australia did is to implement CryptoGuard's detection concept as part of the Parfait extension. So now Parfait, with our help, can scan crypto API misuses as well. In Oracle, it's bought some microsystems, so they're big on Java. And this is a result that they test Parfait against the 11 internal Oracle projects. So some of them are pretty big projects. And here we have the top. Here the gray bar is the line of code, and this is log scale. And the other bar is a runtime runtime, and this is here is also log scale. This is seconds. The bottom half is the number of alerts. 11 project, many lines of code, average is 400,000 lines of code, only have 42 vulnerabilities with no false positives, and the average runtime is several minutes. And so this is a fantastic, fantastic results. And of course, what Parfait did is they optimize the program analysis in a way into tiers, like shorter scanning, longer scanning, and so they have a very innovative way of prioritize the scanning, the order of the scanning. So it works out great. Parfait was also tested on CryptoAPI-Bench, and then this is independently developed a benchmark, and they also did very well. Recall means how many actual vulnerabilities are reported, and so higher the better, and this is pretty strong result. Precision, because our benchmark has path sensitive benchmark that almost none of, to my knowledge, none of the existing tools, including CryptoGuard, is implementing this. And this is related to the if statement. You know, if you have one branch and another branch, one is secure, the other is not secure, and most existing analysis would just say both branches are not secure. So it's over approximation. And so and very rarely we find those cases in practice. And so this is, we're extremely happy that our benchmark and our detection approaches was used by Oracle. In addition, Oracle seems to have really great code, great developers writing high quality crypto code. Very quickly before I end, I want to mention our ongoing work on crypto API recommendation. This is, we realize that maybe, you know, detection is one part. Maybe as developers writing code, we can have some solution that give them hints which API should be used. And so this is an example on the left. If you're a developer, you have already written, you know, up to line 5, then which API to use. Among all the choices here, the first one is a correct choice. And sometimes it's not very straightforward because there are high frequency choices, more obvious choices, in terms of, you know, what is your immediate, what is line 5, then, you know, associated with which line that associated with line 5 and with high probability may not be the correct answer, and so you have to do a little bit more, you know, going back, and so we have worked on this since like several years, and so so far we have achieved a really great accuracy in terms of predicting the last API in a sequence. Of course, this is still a long way to go in terms of being used in practice. I'm glad that the community is really picking up this pace in terms of recognizing the importance of solving deployment issues. Real world crypto from IACR, and last year I chaired the dissertation award at ACM SIG-SAG. We gave the award to Felix Gunther, whose thesis is on TLS implementation security, ACSEC conference, which is happening this week. We have a deployable and impactful security, and SecDev is another conference addressing those issues. So a long way to go. One of the another thrust that we have been working on is education, tutorial that we gave on secure coding, and so it's gonna take a long time, and I think it's take a long time. And that our CryptoGuard tool was reported by ACM Communications. So we're glad that, you know, people realize, we did, when we published the work, we had so many issues because people say, oh, this is not novel. This is, people know crypto API misuses. That's it. There's no need to work on this anymore. And so, it took me, it's just very difficult to convince some of the reviewers that no, that's not the end. Knowing their vulnerability is not the end. It's our responsibility as a security researchers and crypto researchers to solve the problem, to actually produce tools and solutions that help people write better code. That probably is the end. And so I think it's solving problem driven, not publication driven, and I think that the security community is slowly start to realize this, and some of the references are here. So that's it for my talk. Thank you so much, and I'll just stop here, and we can have some discussions.